Form 5 Mathematics, Chapter 7, Section 7.3, Part 1. Section A. Here in these sections, we will learn how to find the coordinates of the intersections between a straight line and a circle. Let's recall what we have learned in junior form. We have learned how to find the intersecting points of two straight lines. Here is an example. We have two equations, two unknowns. For these two linear equations in two unknowns, we can have two methods to solve the unknowns x and y. To find the intersecting points means we have to find the solution that satisfies both equations. So for the first method, we have learned the method of eliminations. For this method, we either subtract or add the two equations to eliminate one of the unknown. Say, for this case, we can just add equation 1 to equation 2, and then we will have 2x equal 3, and then x equals 3 over 2. And then substitute back x equal 3 over 2 into either equations. We have 3 over 2 plus y equal 1. So for this case, y equals negative 1 over 2. So we have the solutions. Or we can use another method, the method of substitutions. For this case, we can choose either one of the equations, say by equation 1, and we can choose one of the unknown be the subject of the equations. Say we make y the subject of the equations, and we label this as equation 3. And then we can substitute 3 into equation 2. And then you will have x minus y replaced by 1 minus x. Then still, you can solve x equals 3 over 2. And y similarly, you can get the value is likely 1 over 2. Actually, the method of solving the two linear equations in two unknowns is the same as the case when we want to solve the solution that satisfies a straight line and a circle. Here, if we want to find the intersecting points of the straight line and the circle, that means we have to solve the simultaneous equations, one linear and then other one is quadratic. And for this case, you cannot use the method of eliminations. It does not work for one linear and one quadratic. Here, we will use the method of substitutions. Let's study some example. Example 1, quick practice 7.11. In this figure, you have the circle S touches the straight line L1 at the points A and cuts the straight line L2 at 2 points B and C. And you have to find the coordinates of A, B, and C. So here, first, let's consider the intersections between L2 and S. That means we try to find the coordinates of B and C, the two intersecting points. Here, we try to solve the equations. So we just write down equations of L2 and the equations of the circle S. And we label them as equation 1 and equation 2. Similarly, here, first, we make x or y be the subject of the equations of the linear equations. Here, it is easier to make x be the subject. And then we label this as equation 3. And then we substitute equation 3 into the equation of circle, equation 2. And for this case, you have to replace x by 2y minus 8. Beware of the bracket. Here, try to simplify and solve these quadratic equations in one unknown y. Expand and simplify. You will get the following. Try to group the like terms. We have 5y squared. And the y terms, we have minus 16y. And finally, the constant term, we have plus 175 equals 0. This is our quadratic equations in y. So the solutions for these equations actually are the y coordinates of the two intersecting points B and C. We try to simplify and solve by either cross method or by using your calculator. You will get y equals 7 or 5. So for each of these, you find the corresponding values of x. When y equals 7, by using equation 3, you got 2 times 7 minus 8. So this is 6. And then for another point, you have x equal 2 times 5 minus 8. So you got 2. From the graph, you can write down the solutions. The coordinates of B are 2, 5. And C are 6, 7. After we found the coordinates of points B and C, let's go ahead to find the coordinates of A. That means to find the intersection between L1 and the circle S. Similarly, we try to solve the simultaneous equations. We label the equation of L1 as equation 4. And still we have the equation of circle as equation 2. So here, by the equation of straight line, by equation 4, we make x the subject of the equations. And this is equation 5. So here, for this case, we substitute 5. This is from equation 4, the equation of L1, into equation 2. And similarly, we place x by 2y minus 13. Still, please put the brackets for the values of x. And try to simplify by using identities, and then you will get the following. Still, this is a quadratic equation in y, and you try to simplify. Group the like terms. And you will get 5y squared minus 80y. And plus the constant terms, you get plus 3 to 0 equals 0. This is the general form. And by pressing your calculator, you can find y equals 8. So, when y equals 8, you can find x by equation 5. And then you can get the values of x is 3. So finally, you can write down the point A is 3, 8. Part B. Do the circle S and another straight line, the vertical line L3, x equals 1 intersect? If yes, you have to find the coordinates of their intersections. Here, still, we consider the intersection between L3 and the circle S. This time we label L3 in the same fractions, so we label it as equation 6. And the equation of circle S is still equation 2. This time you just directly substitute 6 into equation 2. And so you replace x by 1. And after simplifications, you will get a quadratic equations in y. And you have to find the values of y for this equation so that you can find the coordinates of the intersections. But after you press your calculator, you find it is math error. That means for these equations, there is no real solutions. For this case, you have to show by calculating the values of the discriminant of these equations. The discriminant of this case is b squared minus 4ac. So the values is negative 16 and it is less than 0. So we can conclude the quadratic equations has no real solution. And finally, that means the answer is no. The circle and the straight line do not intersect. After we finish example 1, you may find that it is quite boring to do the step because the steps are very similar. We just substitute the linear equations into the equation of circle. Then you will get a quadratic equation in either x or y. After you solve the values of the unknowns, you can find the intersecting points, find the coordinates. And let's make a conclusions after this example. When we consider the intersection between a straight line and a circle, we can have 3 possible cases. The first one, when you consider L2 and the circle, we have 2 intersecting points. And then for case 2, when we consider the straight line L1 and the circle S, we have 1 intersecting point. And finally, when we consider the straight line L3 and the circle S, here we have no intersecting points. That means 0 intersecting points. So here, in general, there are 3 possible cases when a straight line L intersects with a circle S. Case 1, there are 2 intersections. Case 2, there is only 1 intersection. And case 3, there is no intersections. And let's study a general case. For any straight line L, y equals mx plus c. And the general equations of a circle S, x squared plus y squared plus dx plus ey plus f equals 0. We label them as equation 1 and equation 2. And similarly, by substituting equations 1 into equation 2, we replace y by mx plus c. Then we try to simplify these equations. We have these equations looks complicated, but when you group the like terms, x squared terms, x term, and then the constant term, you have the following. We have 1 plus m squared, x squared, and then plus 2mc plus d plus emx, and plus the constant term c squared plus ec plus f equals 0. This is actually a quadratic equations in x. So if we can solve the values of x for these equations, we can find the x coordinate of the intersecting points. So correspondingly, if we want to know the number of points of intersections of a straight line and a circle, we can consider the discriminant of these equations. We label this as equation star. So the discriminant of star will be equal to the coefficient of x b squared minus 4ac. And you may find it is quite horrible to memorize this formula of the discriminant of the equation star. So don't worry here. You needn't remember this. You have to only remember the following. After you substitute the linear equations into the equation of circle, when you get quadratic equations in either x or y, you just consider the discriminant of these new quadratic equations. And for the discriminant, when the discriminant is greater than 0, then there is two distinct real roots. And for discriminant equals 0, there is one real root. And when the discriminant is less than 0, there is no real root. So correspondingly, we can fill the table. For discriminant is greater than 0, there are two intersections between the straight line L and the circle S. When discriminant is equal to 0, there is only one intersection. when discriminant is less than 0, there are no intersections between the straight line L and the circle S. And pay attention to case 2. For this case, you will find discriminant is equal to 0. And the straight line here, we will say it touched the circle at only one point. So the straight line L is a tangent to the circle. Conversely, if a straight line L is a tangent to the circle, when we substitute the straight line L into the circle and get a quadratic equations, then the discriminant of that equations will be equal to 0. Let's study 2 more examples. Here, we are not going to find the coordinates of the intersecting points, but we are asked to find the number of points of intersections. Actually, the steps are similar. What you have to do is to make one unknown be the subject of the equations for the linear equations. Say it is easier to make y. We get this. And similarly, sub 3 into 2. And then you will have this quadratic equation in X. Try to simplify it. And you will get 5x squared minus 12 20x plus 15 equals 0. And you can further simplify at this. And this is the quadratic equations that is used to find the coordinates of the x coordinates of the points of intersection of the circle and the straight line. But you are not asked to find the coordinates. So we just consider the discriminant of these quadratic equations. And this is equal to b squared minus 4ac. So the values of the discriminant is 4. And this is greater than 0. So you can conclude there are 2 intersections. Example 3. Here you are asked to find the coordinates of the points of intersection of the straight line y equals 2x plus 3 and the circle. Still, we use the method of substitutions. We just sub 1 into 2, and then you will have x minus 1 whole square plus y is replaced by 2x plus 3. And try to simplify it. And this is 2x plus 5 whole square. So you will have 4x squared plus 20x plus 25 equals 6. Move all the terms to the left-hand side and make one side equals 0. And you will have a quadratic equation in X. For this quadratic equation, when you press your calculator, you find there is no solutions. So you just write down the values of the discriminant to show there is no intersections. no real roots for these quadratic equations. You have b squared minus 4ac, and the values is negative 76, and this is less than 0. So you can conclude actually there is no intersections. Now it is your turn. Please do the classwork practice 7.12. Please at least do one part of this quick practice, say part C. Here, you will find the coefficients of both x and y are not equal to 1, so the steps are more tedious. Do try at least once and pause the video, and the solution will be solved later. For these questions, the solutions is as follows. Because the coefficients of both x and y are not equal to 1, so you can choose either x or y be the subject of the equations. Say, if you choose equation x, then you just substitute this into the equation of circle. And be careful of the brackets. And here, when you try to simplify, you multiply the equations by 16 to remove the denominator. Remember that you have to multiply each term by 16 to get our quadratic equations in y. And for this case, you have to determine the number of intersections. So you just calculate the discriminant, and this is equal to 0. So the conclusion is there is only one intersection. Now, please spend some time to finish the daily exercise. Just 3 questions. Try to do yourself and submit in this lesson.